All right. So thank you so much for this beautiful introduction. Thank you especially all of you for being here attending this talk. We have a very packed agenda, so let's start. I'm going to start with an introduction on browser-based HMIs. I'm going to go through a breakdown of all the findings that we had discovered. I'm going to show an attack demo where we're going to drop containers from a robotic pork crane. And I'm going to conclude with a summary and some key takeaways. What is exactly a human-machine interface? This is a term that is well known to OT professionals, but may be obscure to some of you. According to the NIST, it's the hardware or software through which an operator interacts with a controller. It basically allows you to do two things: monitor a process and control it. It can range from a physical control panel with buttons and knobs, etc., to a fully-fledged industrial computers running some HMI software. The traditional HMI model is pretty much the one that is depicted in this picture on the right. So you can see that it's pretty much buttons on a black and white display. It's not for sure super user-friendly, not flexible or scalable at all. So to solve these and other issues affecting the traditional HMI model, the last few years have seen the rise of web-based HMIs. What is exactly a web-based HMI? It's an HMI that is based on web technologies. It can be operated through a dedicated physical device, but actually from any device. So in this picture on the right, you're seeing an iPad that is running a General Electric's HMI. It has rich data visualization. It has user-friendly controls. It's super user-friendly and flexible. It's like operating an app, basically. And by the way, in this presentation, I'm going to use the term web-based HMI to refer to the software layer, the term browser-based HMI to refer to the hardware device that is depicting it. What is a browser-based HMI? It is essentially a rack tablet with mounting clips, nothing more than that. The display is almost always a touch panel. Yeah, sometimes there are some HMI models that have an HDMI output or some USB imports, but you are mostly supposed to use it through the touch panel. It usually embeds an ARM processor. The operating system is mostly Linux, but some models even have Android. I mean, it's like using a tablet, after all. And as you might expect, the browser represents the most important component of a browser-based HMI, so let's see some details. In the majority of cases, for Linux, you're going to find either a vanilla or customized version of Chromium. Another popular alternative is the Qt Web Engine, which, however, is still Chromium. It's rare, but some other vendors prefer to use Firefox or others. In Android, instead, you're going to find the old AOSP browser, even Chrome, the very same Chrome that you can download through the Play Store. And one thing that is important to mention is that on Android, the administrator is usually able to install other browser, either through the Play Store or by sideloading an APK. On a browser-based HMI, the browser is almost always in a lockdown state. So the operator can interact with the web HMI, but cannot do much more than that. We use browsers every day in our personal devices, and very rarely we associate the installation or the presence of a browser strictly with a risk. However, this impact and this threat model radically changes when this browser is installed in a server system. And when the server system, let me use this term, is used by heterogeneous operators, and when, of course, the server system controls an industrial process. For instance, let's see the image on the right as an example. This image right now is currently depicting a dreadful vulnerability, which is the ask where to save each file before downloading. Because if you think about it, when we download a file, what we are actually doing is we are instructing our browser to write an arbitrary file, thanks to this option, into an arbitrary path. And this is an arbitrary file write. And an arbitrary file write in the right conditions is an RCE. Now you're starting to think why just having a browser on board can be a risk. Oh, sorry. I want to start this presentation busting a myth in the sense that for Chromium, I've seen many implementations locking down the browser through this kiosk option. This is poorly documented, and this option was never meant for security, actually. Just runs the browser in full screen and hides the status bar. Nothing more than that. The correct way to lock down Chromium is via policies. However, when you start thinking on it, you're going to find more than 1,000 policies defined to lock down Chromium. So, I mean, the risk of misconfiguration is non-negligible. And similar things can be said for other browsers. Having talked about the browser, let's now talk about the services that are usually involved for the correct working of a browser-based HMI, that are the browser-based HMI management service, the web HMI application itself, and the web HMI management service. For the browser HMI, it is often a web application so that the HMI can be configured to the HMI itself. Interesting. It allows to set the target web-based HMI URL, manage the trusted TLS certificates, etc. As for the web-based HMI, of course, also in this case, the web HMI is a web application, but also the management service, again, can be, and most times is, a web application. The management service is usually there to allow you to build your own HMI, but sometimes you can even upload the HTML, JavaScript, CSS, and of course also the server-side code of your own web HMI. There are two possible architectures. So in one case, the web HMI is hosted on the browser HMI itself. Another possibility is that the web HMI is hosted on a separate server, and the browser HMI just runs as a thin client, basically. And when hosted on the browser-based HMI, it is sometimes common to find that all those services coincide in only one complex web app. But this is interesting because if I get an XSS anywhere here, I can basically compromise everything. As for the access control levels, you're going to find, in most implementations, those ones. You're going to find an administrator. It is self-explanatory, nothing interesting to say. You're going to find this engineer that in many implementations is pretty much an administrator that doesn't have access to the user management and maybe some low-level settings such as the IP address, for instance. But apart from that, can do anything else. This is interesting, however, because if I need to perform an attack that requires some kind of user interaction, it is likely that just by targeting an engineer, I can succeed. As for the operator, it has the sole privileges to operate the web-based HMI. And what I want to say about the operator is that in many implementations, to quicken the boot process and avoid that the password needs to be manually input, just for the local interface, many products allow you to enable the passwordless auto-login for a specific user. And of course, this can be abused. Let's also precisely discuss which are the main risks of HMIs according to the MITRE's attack framework. In terms of initial access, expect some kind of exploitation of remote services. In terms of execution, you're going to spot most of the times a command line interface or even a graphical user interface. If you remember, some time ago, there was an hack to a water treatment system in Florida. In that case, the attacker accessed the HMI through TeamViewer and then just operated it through the graphical user interface, nothing more than that. In terms of collection, of course, the attacker is going to need some time to understand what the HMI is controlling. As for the inhibition of response function, yeah, I can do some kind of modification of allowed settings or service stopping, but for sure, the two main techniques that an attacker is going to apply against an HMI are the manipulation of control and the manipulation of view. We're going to see examples of almost all of these techniques in our attack demo. And to counter-effect these techniques, regarding remotely exposed services, all vendors enforce, let's say, a variable degree of security. But when focusing on the physical operator, the situation gets funny, I would say. In the sense there are two basically opposite philosophies that a vendor may decide to adopt. According to one philosophy, basically the browser-based HMI is an industrial plant where manifold employees with heterogeneous roles, they don't necessarily are trustworthy, so we can't really trust them, can interact with it. So local access to the management service must be locked down as much as possible. So according to this philosophy, you're going to find that the local interface is as locked down as the remote one. But there is a completely different and opposite philosophy that is equally implemented. That is, the physical operator, after all, has by definition physical access to the device and possibly to the process. And sometimes also, there are some situations where the physical operator might want to do some emergency operations, some emergency task. Thus, it is useless and sometimes even harmful to lock down access to the browser-based HMI management service. And so security is applied only for remote connections. And according to this philosophy, you're going to find security on remote, but on the local interface, almost all of the APIs or all of the features are unauthenticated, or maybe there is a subset, but you're going to find, say, a set of requests that are completely unauthenticated. Okay, so enough for this introduction. Let's go straight to our findings. Couple of words on our victims of our research. So in our research, we have analyzed the Siemens Peak SAM30.E, which is a building automation specific HMI. We analyzed the CellArtac, which is a suite that, among others, comprises a web-based HMI specific for electrical substations. And similar things can be said for the Hilux RTU that embeds an HMI. As for the last two ones, those are the Phoenix Contact and the Bosch Rexroth. Those are basically general-purpose HMIs. And notably, of all of the first four of these HMIs are Linux-based. The last one, the Bosch Rexroth, is an Android-based HMI. And here we are. So this is the list of the 11 most common ways through which you're able, in 2023, to practically compromise a browser-based HMI. So in the next slides, you're going to see how, starting from these issues, optionally chaining other flaws, but always starting from these issues, we were able to get RCE with root privileges on all 5 devices. As we believe in a practical approach, we are not going to discuss these findings from a theoretical perspective, but using real-world vulnerabilities found by us as a case study, showing all deriving impacts step by step. So, let's start from the first one, that is the improper allow list on starting pages and/or browsable URLs. This is, by far, the most prevalent vulnerability in browser-based HMIs, and is simply derived by the fact that the user can browse other URLs or other URI schemes, and we are getting to the point. So, you might not know that your browser does not support only HTTP or HTTPS. Actually, your browser, when it navigates to a file URL, acts like a file browser. So now I can traverse the file system of the HMI and list arbitrary files and folders. How about opening those files? Here is the content of etc shadow of this Siemens HMI. And here is the content of the private key that is being used for the TLS service or the management interface. And all of this can be done unauthenticated. How about JavaScript? I mean, by navigating into a JavaScript URL, I can now basically obtain XSS anywhere I want. And as I told you before, in many management pages, you can configure the starting URL. So how about setting the starting URL into a JavaScript? So now, whenever the HMI boots, it's going to execute my code before everything else. And finally, what is less maybe known is that there are many, I would say, for instance, in Chrome, there are about 30 to 40, if I remember correctly, something like that. There are some debugging URLs that your browser supports. Those URLs are there for debugging purposes, of course, but they have practical consequences. And for instance, when you browse in your Chrome browser, the induced browser crash for real URL, your browser crashes. But I mean, if you do this on an HMI that controls an industrial plant, you're going to obtain a denial of service. And if I put this as a starting URL, this gets basically a quasi-permanent denial of service. Let's see the second one, that is improperly configured file download functionality. In that sense that the HMI, the browser HMI, is allowed to download files more or less. How can we leverage this to evade the kiosk mode? It's actually quite simple. It's just a matter of finding in the legitimate web HMI any functionality that allows you to download one file, one single file, whatever it is. And then let's just press the show all button. And here we are. We just evaded the kiosk mode in the sense that now we are inside a Chrome debugging URL, but we can also access the address bar. So what else can we do now? Well, how about testing the arbitrary file write that we mentioned before? So now I'm going to go into the settings page of Chrome. I'm going to enable this setting. So now I can write an arbitrary file into an arbitrary path. Now, I'm going to navigate into a web server that is under my control that I previously instructed to provide to basically download you back a heterogeneous version of a system file. let's overwrite the system file. And by the way, I can do this because the browser was running as root, and I'm going to tell you more about this later. Here we are. We got a reverse shell. OK, improperly restricted file opening functionality. So here we had an Android HMI that, apart from locking an application in the foreground, was not applying any restrictions, basically, on the browser per se. So how about downloading and opening an APK? So I'm now, again, browsing to a web server that is under my control. I'm opening this download file. And the funny thing that happened at this point is that usually Android warns you that, I mean, you can't install third-party apps by, for instance, opening an APK, but was happily including the link to the settings page where you could enable this functionality, and this was rendered inside the kiosk mode. I mean, we're still inside the kiosk mode. You can maybe see on the bottom right of the picture the exit kiosk button is in the foreground. And we're still inside the kiosk mode. We are still an unauthenticated user. So now we can enable this setting. Here we are. We have achieved our installation of our malicious application. And now we have, let's say, code execution on this device. And by chaining other vulnerabilities on this HMI that were basically affecting the SE Linux feature, we were finally able to obtain a root ADB shell on it. In finding number 2, you might have asked yourself, OK, but what if we're, and also in the previous one, actually, what if we're unable to reach an attacker control server? In that case, the browser-based HMI was not enforcing any restrictions also on the file upload. And given that the web-based HMI offered the file upload feature that was weakly protected, and I'm going to explain you how, full transfer of files from and to the HMI was possible, leading to a high-risk chain. So in my penetration testing career, I've always encountered this finding of a weak file upload, let me call it in this way, where you could basically, where you couldn't achieve code execution, you couldn't actually overwrite any other file, but you could indeed upload any type of file, whatever it was. And it was happily accepted by the server. And every time the customer was always asking, OK, but what is the impact? Here is an impact. For instance, thanks to this vulnerability, because it is a vulnerability, I can now exfiltrate files from the HMI, and I can transfer files into the HMI by basically abusing a legitimate functionality, by using it as a gadget, basically. And I don't even need to spawn anything on the network, or, I don't know, relax firewalls or something like that, of course, which is a more complex thing. I can just using legitimate functionalities, I can achieve this. Here is yet another very common flaw that is found in many browser-based HMIs, that is the missing verification of the TLS certificate. This is due to the fact that it is rare to find in asset-to-nest networks an internal CA maintained for TLS connections. And as such, to avoid showing warnings to customers, many vendors decided to just omit the check, omit this exactly, to not display anything and accept anything. Of course, this can result in a TLS man-in-the-middle, but we're going to see a specific case study where we were able to achieve more than this. So basically, this was a management service from Cell, and in this web HMI, you could define a web proxy in the sense that whenever you created one, you could browse into URL of the management service of this HMI, and the device would fetch a remote page for you and render it back under the same domain of the management service. But it wasn't checking for the TLS certificate. So how can we abuse this? So first, let's do a TLS man-in-the-middle, because after all, it's going to accept anything. Let's reply with some arbitrary JavaScript that now gets rendered inside the same domain of the management service of this browser HMI. And given that there was another functionality in the same service that was vulnerable to command injection, if, let's say, we compromise the correct user, here we are. We managed to obtain, again, a reverse shell just by starting from a TLS man-in-the-middle. To conclude this set of vulnerabilities specifically affecting the browser, another very common vulnerability in many browser-based HMIs, as anticipated, is the execution with unnecessary privileges, which in practice translates into the browser running as root and/or with excessive privileges, such as the no sandbox option enabled. This happens because, to keep things simple, many vendors opt to run everything on the HMI as root, but of course some browsers refuse to run as root without relaxing other things such as the sandbox, and the vendor decides to disable the sandbox. Why is this a vulnerability? Well, from one end, we have just seen the previous findings how this was exacerbating the impact of other vulnerabilities. However, what makes this a fully fledged vulnerability and not some kind of weak design are those two conflicting conditions. On the one hand, it is expected that you can import an HMI project from the outside world and reuse it or start on it to build your own HMI. And on the other hand, there is an unavoidable and non-negligible delay between the disclosure of a browser vulnerability and the actual patching of the vulnerability by the asset owner. I mean, this is a version of Chromium that I showed you before in a previous slide. And this was taken from a browser-based HMI firmware of 2022, so last year. And in this 1 year and a half, approximately, where this was from like mid-2022, this firmware has already accumulated more than 700 high-risk vulnerabilities. Of course, the figures might be wrong in the sense that they might be missing some backported patches, some configurations, of course, but you got the point. We can't simply allow a browser to run in these conditions. So far, we have seen attacks entirely only related with the browser. However, it must be reminded that the browser-based HMI management service is a web application. A web application can have vulnerabilities. So another very common, unfortunately, way through which you can compromise your browser-based HMI is by exploiting one of those vulnerabilities on the management service. So here is the actual chain that we use in our attack demo that you might have seen at our booth. So this attack chain all started because there was this endpoint, this web endpoint in the management service that was returning the read-write community string of the SNMP service. And this endpoint, after some testing, turned out to not enforce authentication, in the sense that I could send a request without the cookie and get back the read-write community string. But then we started looking into it, and we soon noticed that the agent that was parsing the SNMP options for one specific option was happily taking their value and putting it inside the popen without any further validation. So guess what? Reverse shell with root privileges, by the way. And by the way, we have just released on our website the patch 3 series of our Phoenix contact analysis. So come to our website to know more about this chain and come to our booth to see it live. Although we've just discussed how a generic web-based vulnerability can be used to compromise an HMI, I would like to add a couple of more words for two well-known web vulnerabilities out there that are cross-site scripting and cross-site request forgery. Cross-site scripting, no words needed, is a devastating vulnerability in this world. So given that we have a web interface that displays and controls a physical process, running malicious JavaScript on that interface easily implies a plethora of risk, from the surreptitious process monitoring to the manipulation of view and controls. Now, about the cross-site scripting, I don't want to add too much in the sense that basically testing for XSS is the same as testing for XSS here in the sense, it's the same as testing for XSS in an IT interface. However, what I want to tell you is that in many OT and IoT focused frameworks, let's say for broader compatibility, I mean, in an OT network, you're expected to find heterogeneous devices from many years. We notice, according to our experience, that we're happily accepting GET requests in place of POST requests many times. So whenever you find a POST XSS in a request, for instance, in this case, it was found in a body parameter of this management service, try to convert it into a GET request, because if this gets accepted, you get a very, very powerful one-click compromise attack. in the sense that now I could send this link to an operator, to an engineer, and just by making sure, by tricking this user into clicking on this link once, I could completely compromise the web HMI. And by the way, of course, if there are some opportunities to chain this with something else, for instance, a command injection, again, reverse shell with one click. Now, about cross-site request forgery. Wait, but wasn't CSRF dead? For sure, the introduction of mitigations such as same-site attribute has largely reduced the risk of CSRF attacks. However, again, we must keep in mind that OT devices have a lifespan of many, many years, so know if the asset owner still uses an old browser and XP is still a thing, in OT network. Know if the request is unauthenticated, for instance, when the service is localhost only. That happens a lot. Know if the vendor uses other authentication schemes, such as digest access. And there is a big vendor that I want to mention here that still uses digest access for their own web applications. And not by default if the framework supports GET for state-changing requests for product compatibility. We have just seen it. So CSRF is still a thing here on OT and IoT devices. And one very common CSRF issue that we have spotted, unfortunately, affects the import of the HMI project itself. And do you remember that the project of an HMI contains JavaScript, right? And do you remember that in those cases where everything was hosted on the browser HMI, we had a complex web application that was running anything? So here on this Siemens HMI, we are going to see a complex chain that exploits a CSRF vulnerability in the web HMI management service to add an additional HMI project. This project contains JavaScript that moves laterally into the browser-based HMI management service, retrieves the password hash of the user because that was leaked by the management service, and then uses this information to obtain RCE through the authenticated backnet restore feature of this HMI. Let's see step by step. So it all starts with a CSRF attack. So the first step is to convince the victim to visit a malicious web page while logged into the web-based HMI. And if you think about it, that is not so uncommon, because if you are an operator or an engineer and you want to do something remotely, you're going to keep your browser on all the times to control the process on your desk, on your workstation, whatever. But you might want to do something else in the background. And if you did this with the same browser and with the session open on the HMI, what happened is that any web page that you rendered inside your browser could have sent could have done a CSRF attack and uploaded a new HMI project. This HMI project could have leaked your password hash, could have obtained it. At that point, what we spotted is that by looking at the authenticated service, API of the backnet of the backnet request, we noticed that the restore feature at some point was putting the file name of one of the files inside this beautiful execv of binsh without even validating anything. So guess what? Reverse shell obtained. All right, so now for the next two final findings, we're going to shift our attention to the physical operator. Do you remember the slide when we talked about the threat model and specifically about vendors deciding to grant more privileges to the physical operator? Again, it's important this is well developed. So let's see an example. In this case, there was this HMI that was trusting completely the X-forwarded for header that was added by the Nginx reverse proxy. So basically, there was an Nginx reverse proxy, and then there was the final server that was actually processing the API. In this case, we tried as much as we could to make it accept a spoofed header. We couldn't. However, at that point, we realized that those requests that were unauthenticated were also not protected against CSRF. Probably that was because the vendor thought, it's unauthenticated, so who cares? What's the matter of protecting it against SRF? But what the vendor hasn't thought is that now any single web page rendered by this HMI could have just sent a coarse request to the local interface. And at that point, the Nginx reverse proxy would have just added the X-forwarded for header in the correct way. And it would have trusted it. So to compromise it, It's just a matter of adding some JavaScript anywhere in one of the pages that is rendered by this HMI and send a CONST request, and we've just bypassed authentication. Of course, we can also chain this with other vulnerabilities and get, again, reverse shell. Finally, for the last finding, we're going to abuse the physical auto-login feature. So do you remember that some vendors offer the possibility to enable auto-login into a specific user for physical operators, right? We're going to see, again, a specific and very funny case study that is based on the HMI of finding number 5, the one of the web proxy feature, if you remember. So in this case, the auto-login feature was implemented by means of a GET request to auto-login with, to the default.cell with the parameter auto-login set to true. And what happened is that if this request was set, the server, and of course if this request was coming from the local interface, the server would happily reply with a valid session cookie for the pinned, let me use the term, auto-login user. Again, we tried as much as possible to bypass this. We couldn't at first, but then there was this funny web proxy feature. How about using it a bit? And what we eventually understood is that if we had the opportunity to compromise, or let's say a malicious operator that has enough access to add a web proxy link, that, by the way, doesn't look too risky, right? So if this operator added a web proxy link to remote URL that is actually localhost, and this operator sent a request to this truly defined web proxy, and specifically to default.cell with the parameter auto set to true, this would trigger an infinite loop of requests, but the first response of this infinite loop of requests was containing, yes, a valid session cookie. And now, remotely, I could completely bypass the authentication, at least have an elevation of privilege. And again, if this user has access to that functionality that was vulnerable to command injection, reverse shell. Finally, the moment you were waiting for. So let's see how we were practically able to abuse some of the techniques proposed so far to tamper with an industrial process, and namely a robotic pork crane, while simultaneously manipulating the view to deceive an operator. By the way, in our demo, we used a Phoenix Contacts HMI that is connected to a Siemens S7-1500 PLC that is controlling a robotic pork crane. So let's start our demo. Here is our beautiful smart city demo. And you can see on the bottom right of the screen the robotic pork crane that is moving the container back and forth from a truck to a ship. Now, in the top left of the screen, you're going to see the web HMI, soon, here it is, that is controlling this process. And you can see that the operator can see the status of this process. It can control it through this start and stop button. And you can see that there are some other information, such as the running light says that it's running or stopping. And there is also this mode feature. Basically, when the HMI was running in automatic mode, the robotic pork crane is running with its usual code. But it can be switched also into manual mode. And when it is in manual mode, let's say that the operator can control manually the robotic pork crane. So let's see how it went. We are now starting our attack that is completely unauthenticated, and we are chaining that exact chain that I was describing before to retrieve the SNMP community string and obtain code execution on the device. And now I got back a BITM proxy shell so that now I can completely control all the HTTP requests that are sent and received by this HMI. And you can see that on the web HMI instead, nothing odd seems happening. I mean, everything seems to be running as fine as usual. But now what I can do is that I can fetch another anti-CSRF token that is exposed by this Siemens 7 PLC. I can now start the manipulation of view. So now all the responses coming back from the Siemens 7 PLC are completely overridden by us. So now the web HMI displays what we want it to display. And now we can finally switch the mode of this HMI and upload our own code. So let's see the result on the physical process. You can see on the bottom left of the screen that everything seems to be running as fine as normal. But in a matter of seconds, when the new loop starts, the robotic port crane is gonna take the container, it's gonna move to the ship and drop it against the ship and back to the sea. And you can see, again, on the web HMI, that nothing at all was happening. In the sense, the operator couldn't know at all that something weird was going on. Wow, we have packed a lot today. So let's conclude this presentation with a summary and some key takeaways. Browser-based HMIs are rapidly getting attraction in the OT and IoT world thanks to their flexibility, scalability, and possibility to reuse well-known web technologies. However, the inclusion of a browser inside an HMI and the transition to a web-centric model comes with a unique set of risks that many vendors, even high-profile ones, have not fully understood. We have presented the 11 most prevalent risks affecting browser-based HMIs today after analyzing models of 5 different vendors, and we have practically demonstrated that by leveraging these vulnerabilities, it is possible to tamper with an industrial process while simultaneously manipulating the view to deceive operators. Now, for the key takeaways, here are some recommendations for end users, for vendors, and for the community in general. For end users, remember to restrict logical and physical access to the HMI because you have seen it, like in a matter of seconds, you can compromise an HMI by having unauthenticated logical or physical access to it. Limit the number of exposed services, that's for sure, as usual. Audit external HMI projects before importing them because you have seen that they can contain anything, and this anything can do something on your HMI, and avoid any interactions at all while basically with external resources while having an open session, because you have seen it again, just a matter of clicking once a link or visiting a malicious web page to completely compromise your own web HMI. As for vendors, carefully set policies to lock down the browser, make it run with as few privileges as possible, and regularly distribute upstream patches, and use and accurately configure battle-tested web technologies because they are going to run for many, many years. And for the community, an evergreen that I'm always going to insert in my slides, basically, apply care while porting solutions designed for the IT domain into OT and IoT products. Always reevaluate the threat model because it's going to drastically change, and consider the impact to the physical world that a vulnerability may introduce because, yes, in this world, vulnerabilities have physical effects. Thank you. I'm happy to take any questions that you may have now. Thank you. Thank you.